Earthquakes have long fascinated scientists and intrigued the general public. These powerful and often devastating geological events have the potential to reshape landscapes, disrupt communities, and pose significant risks to human lives. In this video, we will delve into the real reasons why earthquakes occur, exploring the intricate mechanisms and hidden forces beneath the Earth's surface that give rise to these awe-inspiring phenomena. The primary factor behind earthquakes lies in the dynamic nature of our planet's lithosphere. The Earth's crust is divided into several massive plates that float atop the semi-fluid asthenosphere. These plates are in constant motion, albeit slowly, due to the convection currents generated by the heat from the Earth's core. Where these plates interact, they form boundaries, known as plate boundaries. The three main types of plate boundaries are divergent, convergent, and transform boundaries. It is along these boundaries that earthquakes are most likely to occur. Divergent boundaries occur when plates move away from each other. This phenomenon commonly takes place beneath the Earth's oceans. As the plates separate, magma rises from the Earth's mantle, creating new crust in the process. This continuous process leads to the formation of underwater mountain ranges, such as the Mid-Atlantic Ridge. However, the separation of plates is not always smooth, and as they pull apart, tension builds up along the boundaries. When the accumulated stress exceeds the strength of the rocks, it suddenly releases, resulting in an earthquake. Convergent boundaries are formed when two plates collide or move towards each other. There are three main types of convergent boundaries: oceanic-oceanic, oceanic-continental, and continental-continental. When these plates collide, the denser plate is usually forced beneath the other in a process known as subduction. Subduction zones are notorious for generating powerful earthquakes due to the immense pressure and friction as the plates interact. The most notable example of this is the Pacific Ring of Fire, where several tectonic plates converge, resulting in frequent seismic activity. The devastating earthquakes and volcanic eruptions in this region can be attributed to the convergent boundaries. Transform boundaries occur when two plates slide horizontally past each other. These boundaries are characterized by intense shearing forces, where the plates lock together due to friction. Over time, the stress along the fault line becomes too great, and when it exceeds the strength of the rocks, sudden slippage occurs, releasing seismic energy. The San Andreas Fault in California is a famous example of a transform boundary, notorious for its frequent earthquake activity. The lateral movement along transform boundaries is responsible for significant earthquakes as the rocks undergo sudden shifts. While plate tectonics provide the fundamental mechanism for earthquakes, there are additional factors that can influence their occurrence. These include volcanic activity, human-induced seismicity, such as mining or reservoir-induced seismicity, and even the gravitational forces exerted by the moon and sun during certain alignments. Volcanic eruptions often trigger earthquakes as magma forces its way to the surface. Additionally, human activities, such as mining or the filling of large reservoirs, can induce stress on the Earth's crust, potentially leading to seismic events. When an earthquake occurs, it generates seismic waves that radiate outwards from the epicenter. These waves can be classified into two main types: body waves and surface waves. Body waves, including primary P waves and secondary S waves, travel through the Earth's interior, while surface waves propagate along the Earth's surface. Scientists employ seismometers to measure these waves and determine the magnitude and intensity of an earthquake, providing vital information for monitoring and assessing the impact of seismic events. Advancements in technology have significantly improved our ability to monitor and study earthquakes. Seismic networks worldwide enable real-time monitoring of seismic activity, allowing scientists to detect and locate earthquakes with greater accuracy. These networks provide invaluable data for assessing earthquake hazards, aiding in the development of early warning systems and emergency response strategies. Additionally, sophisticated instruments, such as satellite-based remote sensing and geodetic techniques, contribute to our understanding of crustal deformation and fault behavior, shedding light on the underlying causes of earthquakes. Earthquakes can have severe consequences, including the loss of human lives, destruction of infrastructure, and economic setbacks. Understanding the real reasons why earthquakes happen is crucial for implementing effective mitigation strategies. Building codes and engineering practices have evolved to incorporate seismic-resistant designs, ensuring structures can withstand the forces unleashed by earthquakes. Public awareness, education, and emergency preparedness also play vital roles in minimizing the impacts of earthquakes and facilitating swift response and recovery. While we have made significant progress in understanding earthquakes, there is still much to learn. Ongoing scientific research continues to deepen our knowledge of seismic processes, helping us refine our understanding of the real reasons behind earthquakes. Advances in technology and data analysis techniques provide promising avenues for improving earthquake forecasting and early warning systems. By studying historical seismic events and conducting geological surveys, scientists can gain valuable insights into the behavior of fault lines and potential earthquake sources, contributing to more effective hazard assessments and preparedness measures. Addressing the complex nature of earthquakes requires interdisciplinary collaborations among scientists, engineers, geologists, seismologists, and policymakers. By integrating knowledge from various fields, such as geophysics, geology, and engineering, we can develop a comprehensive understanding of the real reasons behind earthquakes. This collaboration is essential for the development of innovative technologies, improved modeling techniques, and effective strategies to mitigate the impacts of earthquakes. In conclusion, earthquakes are powerful natural phenomena that result from the dynamic processes occurring beneath the Earth's surface. Through the intricate interplay of plate tectonics, fault zones, and various geological forces, earthquakes remind us of the ever-changing nature of our planet. By understanding the real reasons why earthquakes happen, we can better prepare ourselves and our communities for these events. Remember, while we may not be able to prevent earthquakes, we can take steps to mitigate their impact. Building resilient infrastructure, implementing effective early warning systems, and fostering public awareness and preparedness are crucial elements in minimizing the risks associated with seismic activity. As we continue to advance our knowledge through scientific research, technological innovations, and interdisciplinary collaborations, we move closer to a future where we can better predict, understand, and respond to earthquakes. By staying informed and working together, we can build safer and more resilient societies in the face of Earth's hidden fury. Thank you for joining us on this exploration of the real reasons why earthquakes happen. If you found this video informative, don't forget to like, share, and subscribe to our channel for more fascinating content on Earth's geology and natural phenomena. Stay curious, stay safe, and until next time, keep exploring the wonders of our planet.